It's a normal day. You sit down for a tattoo, and then it happens. This is the moment you realized you messed up. What you have experienced is a tattoo artist with a lack of knowledge around what constitutes a saturated line. Not because they don't care. Let's be honest, college courses are lacking. You can go to college for 4 years to learn how to paint, but tattooing is missing from this level of education. When you think about it, that's wild. A tattoo artist is basically completing a medical procedure where they are puncturing your skin over and over. This is why Hand-to-Needle Tattoo Science Lab exists. We bring the science to light. The artist is an expert at knowing what a fully saturated line looks like. The science behind it, not so much. To fully understand a saturated line, let's go to a microscopic level. 1 ink deposit. 1 stab of the needle through the skin. What does it look like? Let me show you. Now that you see what the dot looks like from a microscopic view, what constitutes a line? A line is a row of these dots. They have to be close enough where they overlap to ensure no holidays gaps are present in the line. What you want is a continuous ink wall. Individual strikes that merge into one unbroken deposit dot. So how do we measure this? Exactly what the industry was missing. We decided to be brave to build our system, and we chose an inch as the defining length to start to quantify what a saturated line looks like. After hundreds of hours of testing, we learned, due to needle size, there is a slight difference, but an inch in a linear pulled line constitutes fully saturated between 400 to 420 deposits per inch. In future videos, we will explain how important this really is. It unlocks how to figure out hand speed. Also, we already have a video on hertz and voltage that will help you explain how you have the full equation to figure out hand speed exactly. So a line is fully saturated when over an inch, it has 400 to 402 ink deposits. Any less and you will end up undersaturated with a visual of holidays gaps in your line. Any more and you will have oversaturation leading to longer heal times and even the appearance of blowouts. Now, with this knowledge, how do you apply it? Simply you realize that every line has visual data it is feeding to you. If you stop and analyze every line, you will be able to adjust in the moment and stop from repeating mistakes. If you pull a line and you see blowouts, you need to question, am I moving too slow, or is my machine voltage set too high? Then you can figure out what to adjust voltage or hand speed.